Thank you, everyone. It's a being a great pleasure to have you all here in this session. Let me thank you all for taking out time from your busy schedules and being part of this webinar series that we are doing for Envi and remote sensing. I'm sure that all of you are safe and keeping all your necessary precautions in these COVID times. It has been a real difficult situations in these past months, and I'm sure all of you are keeping necessary precautions to be safe. We at Esri India are tied up with Harris, L3 Harris, as it's called now, for partnering and bringing GIS and remote sensing solutions to various domains, and academia being a very important and a very strategic domain as far as bringing the workforce as well as the knowledge areas which are required in any of the industry or any of the domain we talk about. Today, we are going to talk about the various tools and functionalities, as mentioned by Rashmi initially, which Harris provides for an academician for their teaching, learning, practical hands-on experiences, and not the less the research activities also. With me, my colleague Vimanyu would be there, who would be taking you through these various use cases, demos, in order to explain the various functionalities of how Envi and Starscape have integrated, what are the various tools which are there for crop science, for agriculture, deep learning tools for various disaster management and change detection management for urban monitoring, and many other important things which he is going to talk about and showcase all those things in front of you. We will take the question answer session in the last, and you can meanwhile write whatever you feel like asking about today's session in the chat window. So how actually academic solutions are very important for the for all of us here, because the kind of activities which are performed in education and research at universities, it keeps on increasing, and a large number of students are learning about geospatial imagery and complex numerical data also. So Envi provides a scientific proven technology platform that provides strong analytical tools and inbuilt algorithms and methods for performing advanced analysis on variety of Earth observation data, including optical, hyperspectral, SAR data, LIDAR data from various satellites, airborne and UAV platforms. So today we are going to talk about how academic solutions are available and how Esri India is integrating all these solutions for you eminent professors and faculties and researchers who are attending this session. There has been a lot of synergies working while you are performing your lab sessions, while you are doing those classroom activities. It becomes imperative for these tools and functionalities to be available to the students so as they can perform all these software activities and perform their academic activities for that matter. We provide a lot of Envi trainings, we provide Envi lab licenses to you. There are a lot of webinar series and tutorials which are freely available so as for you to take it ahead and take it to the students also. The students keep on learning. They do perform a lot of Envi, as well as now these days, a lot of programming activities are happening in which IDL plays a very important role. So is Python programming and R programming, which students want to learn so as to keep abreast with the advancements which are happening. The researchers, no doubt, require all that which is their part of Envi and IDL so as to access, analyze, and share all types of data. So these are part of scientifically proven methods which are there, as white papers are also available for all these activities which you require in research areas of yours so as to enable you, right? Quickly, I'll take 10 seconds here maybe to understand the audiences which have joined here are new to Envi, or are they learning, or they are using for academic purpose. So there will be a short poll. I would like to have this poll available on your screens right now. And you can just say 10 or 15 seconds, whatever is comfortable to you, to answer these. And then we will go ahead with the uh, result of this poll as well, which I like to show. Almost like 150 plus participants are there with us in this webinar. So a quick understanding about what kind of a background these participants are coming in from. And now we can stop the poll and we can see the results. So with this kind of poll that we see that almost 28% of participants who have joined here are coming from academia. They are very well doing it for teaching and research purposes. Whereas research scholars are there, which joined here are coming from, which is like a 33% that I see are coming from research. 31% of the audiences are new to Envy, and 6% says they are others. So I thank you all for spending time on this poll, and I'm sure all of you will have a lot of benefited session from these demos and showcase things we will be showing you in the next 50 minutes or so. And I am sure all of you will be benefited out of this session. With this, now I bring in my colleague Vimanyu, who will take you through with the various academic offerings and the tools and functionalities. Over to you, Vimanyu.
Thanks, Preeti, for sharing the insights. So good evening, everyone. So thanks for joining for the webinar. So as Preeti explained that how Envi can be utilized for performing remote sensing analysis, and there are various offerings which are given by Esri India for the academic purposes, for the student trainings, and for the research scholars. But as we know that Envi is a complete robust remote sensing image processing software. So there are a lot of things, like a lot of universities, a lot of space organizations are using Envi for various purposes. So Envi has various modules, which is like Envi Starscape, IDL, and GSF. So all about this, I will be talking in my subsequent slide. So moving on with the Envi image analysis. So what is Envi? So Envi, as I said, that it's complete image processing software. So it's the world's foremost remote sensing analysis software package, available with lots of functionalities related to if you're working on hyperspectral data, you're working on multispectral data, you're working on SAR data, you're working on drone data. So lots of raster data are nowadays available in the remote sensing domain, so which people are using for various applications. So we need a software package which can utilize, which can process, which can analyze all those things, and you can use that software package to represent your data in a very meaningful and insightful way to the general public, to the decision makers. So Envi is a single shot thing which can be used for that. So Envi is widely used by GS professionals, scientists, research scholars, students, and over the entire globe. In India, most of the IITs, space research organizations, state space research organizations, various government agencies are using Envi for their application. So Envi comes with a lot of modules which include like Envi deep learning, Envi feature extraction, Envi atmospheric correction module, Envi crop science, Envi Starscape analytics. So there's lots of module available which can be utilized for your application. Now coming on to Envi. So when we are working nowadays, so Envi can be deployed over your desktop, over your cloud, and even in the form of enterprise things. So Envi is not restricted to only your desktop thing, so it can be deployed over your cloud. So the license, so you can distribute your data within your organization, you can share your data within the organization, and you can dispense your data to various decision makers, to various policy makers, so they can better see and they can check how their data is looking over for their application. Now when we are doing remote sensing, so nowadays there are lots of data available namely starting from the multispectral data. So we are continuously using the multispectral data either from the commercial satellites or from the open source data. So the open source data, like we are using Sentinel-2, we are using Landsat 8, we are using LIS-3, we are using LIS-4. So these all and you name any. So the data from Planet, Worldview, Geo. So you name, there are lots of sensors available. So Envi can be utilized for that. So these data come in a specific format, so the software should support the format. So as you can directly ingest the data to the software and you can start working on directly. So there is no need, no hassle of changing the data so as to make it compatible to the software to start working on. So you can ingest your data directly from the data agency and you can bring it to the software and start working it for your application. So coming on to hyperspectral data. So hyperspectral data, if you're working for mineral explorations, you're working for agriculture, you're working in soil domain, so hyperspectral data can be utilized. So Envi is a software which can ingest hyperspectral data with lots of spectral library options available to match your end members to find your end members from the raster data, from the satellite data directly. Thermal data, so if you're working on thermal data, you can ingest the thermal data. Coming on to SAR data, so nowadays SAR data is extensively used for various applications. You start naming it from agriculture, flood disaster monitoring, which includes flood mapping, landslide susceptibility mapping, subsidence monitoring. So you name any, SAR data is used nowadays extensively for various applications, various disaster application by even the government agencies, research organization, because of its day and night capturing of the data, day and night independency of capturing data, weather independency. So SAR data can also be ingested into the software. So working with the elevation data, you can create your DEMS from microwave data, from stereo pairs. Here you can create your high resolution DEMS from the data. LiDAR data. So nowadays people are using point cloud data to extract your features, to extract your feature of interest from your data. So nowadays lidar sensors are mounted on drones from where the data is captured, and you need to extract features from them. So Envi lidar can be utilized for extracting your features from the lidar data. Coming on to aerial data and drone data are also used extensively now because of its high resolution, because of you can make multiple flights from the drones to so as to capture the single area, so as in various applications like monitoring urban change, monitoring any forestry change. So various forest agencies across the country are using drone surveys for monitoring forest fires, forest change detection. So lots of applications are available. So the point of explaining about this is like Envi is a single shot thing, so which can utilize all these data for lots of your application at a single point. So next, coming on to, so as I explained that when we are working with these all data, so lots of applications are involved. So you can ingest all those. So Envi is a one solution for all data types of use. Coming on to Envi, so Envi is now used to extract accurate and reliable information from satellite imagery in order to provide extra insights in real data. So nowadays, every day satellites are advancing, and it is necessary for the analytic capability of the software to improve with the increase in the resolution of the satellite. So nowadays you see the satellite data is coming with even 0.5 meter data, 0.5 meter data. So software should have all the capability and analytical capability to ingest that data and to perform and allow the user to extract the information which he wants to from the data. So Envi can be utilized. So data support, which I mentioned in the previous slide. So data supports with lots of data support. So you can ingest that data. Even with the increase of number of spectral bands and revisit time of satellite, advanced analytical tools are becoming very important for performing insights in real time. So for disaster management things, for monitoring purposes, and many other functionalities. Now, across the industries, Envi has been considered as leading data image analyzing software to quickly and easily and even accurately extract geospatial information from the remotely sensed image. For that, we have some of the key automated workflows which are ready to use workflows which can be utilized by the users for performing analysis. So if I name the commonly used analysis, which includes change detection analysis, anomaly detection analysis, viewshed analysis. So they're easy to use automated workflows present within the software, which can ingest your data with whatsoever data you're using. Even you can perform on microwave data, you can perform on multispectral data. So automated workflows are present for that. So the user can take the advantage of these automated workflows for performing this. Now coming on to the extensible modules. So extensible modules, there's lots of modules available, starting from the deep learning modules, crop science module, DEM extraction, atmospheric correction. So I'll be talking about them in the subsequent slides. So there are lots of modules available for the users for their application. Coming on to the ArcGIS division. So Esri being the leaders in the GIS domain, so these software should run parallelly. So the softwares Envi and Esri run parallelly. So all the processes that you are doing in Envi can be taken to ArcGIS Pro. So all the functionalities of Envi and toolboxes can be utilized in ArcGIS Pro. So you can make your tools of Envi and ArcGIS Pro using Envi Toolbox. You can take your data. You can even the Arc Pro data can be taken to Envi. So the interoperability of the software is very much. You can integrate both these software and run parallelly the software, and you can work parallelly so as to interpret your results in a more insightful fashion. Coming on to key capabilities. So key capability, as I explained about the sensor data support. So coming on to the hyperspectral data, so more than 4700 spectral libraries are present from various nodal agencies, which are like NASA,
Hi,
JPL,
Vimanyu.
ASTRA.
Sorry to disturb you. Your voice is not clear. Please check
Uh,
your net connection.
Now it's fine.
Can say again. Say hello.
Hello.
Little
Is it
disturbance.
fine? Is it
Ye-
fine?
Uh, hello.
Hello. Is it fine now?
Yeah, continue. Continue.
Okay. Thank you. So sorry for the technical glitch. So I was explaining about the spectral library. So there's more than 4700 spectral libraries available from JPL, Astro, NASA, which includes features for soil, minerals, man-made features, snow. So these are standard libraries which can be used to match the end numbers that you have extracted from your satellite data, and can be used to name them by just performing the analysis. Image analysis with automated workflows, a lot of workflows available related to change detection.
I think there's some network issue with Vimanyu. I think he'll be quickly just joining back. Yes, he's back in the room.
Hello, Vimanyu. Can you hear us?
Hi everyone, just hold on for a minute. We'll get Vimanyu back. Sorry for the inconvenience.
Hello.
Yeah, Abhimanyu, you're audible.
Okay. So sorry for some technical glitch. Now coming on to Envi module. So we have lots of modules available for Envi. So starting with the feature extraction module. So feature extraction module is basically to extract a specific feature of interest from your raster. So we initially we need to digitize so as to extract the features, but I think now it's gone. So you can use the NVFX. So the option to extract in the various workflows related to example-based workflow, rule-based workflow. So you need to train the data for the software so as to extract a feature of interest. Next is the DEM extraction module. So DEM are continuously and very extensively used in various application purposes related to hydrology, landslide monitoring, and all view shed analysis. So coming on to the DEM extraction module. So DEM extraction is you can do it from the SAR data, from the state of pairs. So SAR data can be used to extract high resolution DEMs, or even to 5-meter resolution, 4-meter resolution, depending upon the data that you're using. Atmospheric correction module, like when we take
I'm sorry for all this technical glitch which is happening, which is quite, part of the network issues which is coming up with his network today. So I'm trying to bring him back on the stable network so as to continue with this presentation, because there are a lot of things which we want to showcase to you today, and he would be just joining back, just trying to bring him back as soon as possible so as to have this session more experiential and learning for you. So just give us another 2 minutes or so. We'll just try to have all the things in place for you.
Hello.
Yeah, Vimanyu.
Yes,
Hi.
you are audible, Vimanyu.
Sorry for this.
No problem. I'm happy that all the audience have bear with the patience.
Really
Thank you
sorry.
all.
Really
Yes,
sorry for
Vimanyu,
this.
you may continue.
Now I'll
Yes.
continue. Yes. So atmospheric correction modules are basically when we are capturing satellite data. So lots of atmospheric error are present related to aerosols, related to various interaction that the satellite signal is having when it reaches the ground and when it comes back to the sensor. So atmospheric correction module is used for correcting all those signals, so as the data that you're getting is atmospherically correct and the result that you're interpreting from it is accurately what you want. So atmospheric correction module is used for that. Coming on to photochromatic module, so photochromatic used is a very, we call it very basic thing that we do in the remote sensing and the GIS domain. So every satellite data is coming with some distortions which needs to be geometrically corrected using either GCP corrections, using ortho rectification. So a photochromatic module can be utilized for doing that in a very easy manner. Now coming on to the most buzzword thing that we are hearing nowadays is the deep learning module. So Envi deep learning is very easy to use module. So the misconception about for performing deep learning that we need to be a strong programming background, we need to be a very strong coder for performing all those analysis. So that's all gone. So Envi deep learning can be so used to quickly create your models, to create your and retrain your classifiers. And no programming is required for performing Envi deep learning. You just need to have a basic remote sensing knowledge and a basic GIS knowledge to perform the deep learning and to use the Envi deep learning. Coming on to Envi crop science, so agriculture is the most important domain that we are working on, so which needs a very high attention, and we need very accurate results because agriculture is the backbone of the country. So Envi crop science module can be utilized for that. So Envi for that in the manner that we can crop monitor health, we can count crops, we can track the changes over time, so as to report any missing of the crop, so as to report any disease if it's happening in the agriculture fields to the concerned authority, so as to look upon into. Now coming on to image analysis, so this part is the mostly widely used in the remote sensing domain, where we perform various classification techniques. So supervised classification, unsupervised classification. So Envi supports supervised classification like SVM, SAM, maximum likelihood, neural net classification, and many other. And for unsupervised, ISO data, k-means are supported within the software. And also the best part is you can have the post classification checking, post classification analysis for performing for recorrecting your results, so as to give it more insights, more accuracy to the classification that you have performed. As I told you about Envi crop science. So as the name suggests, minimize losses to maximum yield. So that's the most important thing that's required in the agriculture field. So farmers which are sowing the crops needs the maximum yield with minimum losses from their field. So with the advancement of the technology, how we can utilize the satellite data, the drone data to achieve this statement. So NV crop science can be best to see where the crop is in bad health condition, where the crop is in good health condition, and the various concerned authorities can be can authorize various persons to look into those specific areas and give more attention to that, so as there are minimum losses and maximum yields. Now this is all about NV crop science. So now what I'll do, I'll directly jump on to the demonstration part, so that you can also have a good insight of how the software GUI is, how we can perform various analysis, and what are the tools available within it. So just now I'll be sharing my screen. Just confirm me if my screen is visible. Now
Yes, Manu, screen is visible.
yeah. Thank you. So now coming on to Envi. So as I told you about, so the sensor support ranging from the optical sensor, radar sensors, thermal sensors. So lots of sensor support is available within the software. You start from Planet, you start from Sentinel-2, ResourceSat-2, Landsat-8, ComSat, you name any, it's supported in the software. Coming on to radar sensors, so spaceborne sensors nowadays, Sentinel-1, ReSat, RadarSat-1 and 2, ALOS Pulsar 1 and 2. These are extensively used in the remote sensing, SAR spaceborne domain. So all sensor support is there, and even these are airborne, so ranging from ESAR, FSAR, so all it's supported within the software. Coming on to the scientific formats. So when we are working with the remote sensing domains, we need to incorporate various scientific data like multidimensional data in related to weather, related to rainfall intensity, so as to give more meaningful insights to the results that you have prepared from the satellite data. So they come in HDF and HCDF format, so Envi even supports those softwares. So here you can see the sensor support, how it's available. So now in my screen, what I'll show is I'll have a quick demonstration. So in my screen, I have used two Sentinel-2 imageries of pre and post disaster things. So the first thing is, now we are continuously calculating spectral indices over the data. So we need a tool to calculate spectral indices. So here I can see it's more than 70 plus spectral indices are available within the software. So here you can see from this raster, you can calculate 57 spectral indices. Whatsoever application you're working on, you can you can calculate the spectral indices. So no need to write no need to write a formula for this. So the software will incorporate the concerned band related to the indice, and you can calculate the indice in a single click. So these will keep on varying depending upon the spectral band information that your raster data is carrying. So it will keep on changing. So for example, in over here, I have calculated NDWI for this. So you can see all the water bodies are clearly marked, and you can extract these water bodies, you can mask these water bodies, so which can be utilized in your flood change detection analysis, which I'll be showing for my subsequent demo. Now coming on to the change detection part. So here is one pre-disaster image and one is the post-disaster image. So both images are Sentinel-2 images, open source data, you can download it. Using change detection, so here you can see we have two workflows. One is the image change workflow and other is the thematic change workflow. So image change workflow basically calculates the difference between pixels, and thematic change, if you're using any supervised classification maps already, you can ingest those maps directly to this workflow and you can calculate the change. So you can see there is lots of change happening due to flood, and the output will look like this. So the blue area indicate the parts where the flooding has happened. So if I toggle on between the areas, so here if you focus onto this area, this is a flooded event, and even software has highlighted this flooded event. So you can calculate these flooded areas, and the disaster management authorities can be notified so as to move and quickly respond to these areas because these are most affected. Even you can calculate the statistics of how much area is affected. You will have a txt file in the you have the statistics in the form of txt file, which will be exported when you're using the workflow at the end of your analysis. So this one was for the change detection thing. Now coming on to the classification part, which is very important and very commonly used. So as I explained about your classification techniques which are available, so starting with the now one more important point that we have added is the classification workflow. So if you are performing any conventional, you want to go by a conventional thing, so you can have your supervised classification technique listed and the unsupervised from here. Is if you have classification workflow, so it's a step-by-step procedure with both the classification techniques. So you can use a classification workflow and you can perform your supervised and unsupervised classification. So I have already done this. So I have performed a maximum likelihood classification with 6 classes over the entire area. So you can see how well it's classified. So very less mixing. Even you can have a post classification analysis for this. So post classification technique is also there to combine your classes, to clump your classes, to overlay your classes, to even generate a confusion matrix if you have any ground truth data. So we need it for accuracy assessment, calculating your producer's accuracy and user's accuracy. So you can create a confusion matrix using the ground truth data that is available with you. And you can perform the analysis. Now coming on to the feature extraction part, which is like most important thing nowadays that we are using to extract the feature of interest directly from your raster. So feature extraction workflow, as I explained, that there are 3 techniques available for that: example based workflow, rule based workflow, and the segment based workflow. So it's the entire purpose of doing this is same, but just the technique is different. So in example, we train the data. In rule, we define a rule based on the spectral properties of the feature of interest that you want to extract, and segment based on the segmentation of your features. You use the segment only feature extraction workflow. For this workflow, I have used example based workflow for extracting these helicopters and some trees from vegetation from the area. So using feature extraction workflow, I have extracted this. So you can see how well the features are extracted. In this similar way, you can extract buildings, you can extract roads, you can extract, you can even make various classes within the helicopter, within the feature. So there's no limit of the number of classes that you can extract. So you can extract number of any number of classes that you want to from your satellite data, from any data that you're using. You can use drone data also, you can use multispectral data also, you can use hyperspectral data also. So it can be utilized for any of the data that you're using. So this one was about the feature extraction workflow. Now coming on to the crop science. Coming on to agriculture domain, so very widely used. So crop science is very important tool nowadays, important module, which can be utilized by various agriculture organization, various organization that are working in the agriculture domain to count the crop. So the first step is, so here is the drone captured data of agriculture field. So these are strawberry fields that are present in the area. Now, first of all, I want to mask these outliers that I don't want to include in my results. Now my data is ready to perform the analysis. Now the first step is to count my crops. So I have counted crops based on the using count crops tool that is present in the extension. So actually I'm not running this because it will take a bit of time. So I have kept the results ready so as to show you how the results will look. So this is how the crop raster will look. So, and even you can see the crop count that is coming in over here. So we have 552 crops which are present in the field. The count is accurate because it's not mixing with anything, because we have first calculated it's on the basis of the vegetation index that we have calculated for the raster. Based on that, actual plants are calculated. So 552 crops are present. So these are validated with the ground also. So these are very accurate count, and you will have a shape file. So you can calculate, you can export the shape files. And now the most important part is what's the ultimate use, how we can analyze the crop health. for better monitoring. So we can generate your hotspots. So hotspots are basically to tell where the crops are in good condition, where the crops are in bad condition, and which areas need more attention and which it needs more caring. So the hotspot analysis will look like this. So it will have a scale ranging from the 1 to 7. So 1 being these either are empty areas, so there is no crop. 7 being that these areas are these are the healthy crops areas. So if I focus on to this part, so you can see here these crops are healthy grown, and if you focus on to this is land, so no vegetation is coming, so it will come to red, so meaning no vegetation. So here you can calculate the health analysis. You can even find the crop gaps. So if you have a multi-temporal data of the same area for a pre and post time, so you can calculate crop gaps so as to see. So the purpose can be utilized in the forest changes. The forest agencies can have a drone survey of a pre and post time data, and they can see if there is any encroachment, if there is any deforestation, if there is any illegal cutting of the trees. So crop gaps can be even seen from the crop science module. Now I'll just again give it back to Preeti so as to set a stage for the coming part of deep learning and Envi scale.
Thank you, Vimanyu. I am sure all of you are quite keen and eagerly looking in these demos. I understand because of the shortage of time and everything, we are just not going really deep into the demos and the complete application tools and functionalities with the limitation of time. But you can try these things with your own access to software, and you may write to us if you're finding any kind of challenges, any kind of support or more information required from us. This is just a stepping stone in this kind of activity which we have started with, and we look forward to handhold you, to support you more and more, so that you can also start bringing in these Envi tools and functionalities in your classrooms and labs. And I'm sure a lot of learning and knowledge is going in. So till now, I think we have covered 4 or 5 of the demos, which included change detection, classification, crop science he has covered, feature extraction he has also covered with indices. So these are some of the things which I have showcased now. And I am setting the stage up for the next level, advanced level modules, which he would be showcasing to you in a while, which would include the deep learning modules and the Sarscape modules, and also the ideal kind of programming level of tools and functionalities he would like to showcase now. So he's just bringing up some of the demos right now because there was a switch of demos, so that's why this lag. But I think we are well in time, and we have a lot of to showcase to you. And he will start with this deep learning.
Yeah.
Over to Imagery.
Thank you, Preeti, for setting up the stage. Now, deep learning is a very buzzword that's happening around. So, Envi deep learning is very easy to use. So, as it's mentioned in the chart here, so it's only a 3-step thing. So, when we see deep learning, when we see machine learning, so lots of codes, lots of lines of codes are written. So it's very confusing and very difficult to understand. But Envi deep learning is very easy to use. So the first step is to create your training data, then create a model, then evaluate your performance. So Envi deep learning is built on TensorFlow, so you can take the advantage of TensorFlow. It's a very easy to use workflow. No need to do any programming. You just need to train your model to any of your application, to any of your data that you're using, and you can classify, you can create exactly the very accurate training models for your deep learning module. So there's lots of applications, so it's very simple to use. Quickly create and retrain your classifiers. You can easily label data, extract features, and iterate, and seamlessly integrate with Envi as well as with the ArcGIS Pro, and work with multi-model geospatial data. So you can work with microwave data, you can work with multispectral data, even you can work with the GIS vector data also. So we have tested it with vector data also. You can analyze vector data so as to extract any feature lines, polygons. So you can do that with Envi deep learning. It's very easy, very extensively made module which you can take advantage of. Now coming on to Envi Starscape. So as I explained about SAR, so SAR is nowadays very extensively used in the remote sensing domain for various applications related to agriculture, flood monitoring, disaster monitoring, landslide susceptibility, biomass generation, even soil moisture estimation. So Envi Starscape is an module in Envi which is extensively used for microwave data processing. And so it includes various workflows. It includes various workflows related to displacement mapping, related to intensity time series mapping, intensity time series workflow, DEM extraction. And within this Starscape, there are also a lot of modules available related to interferometry, differential interferometry, polarimetry, ScanSAR interferometry, and many more. So Envi Starscape can be it's utilized in various various research organization, various space organization for this purpose. Now coming on to Envi SAR analytics. So Envi SAR analytics is a very interesting thing that is added within Envi and within our Pro. So if the user is new to microwave data processing and he is a very beginner in the microwave data processing, so Envi Starscape analytics engine can be utilized by him. So you can have various applications. So there are ready to use applications which are available in Envi Starscape analytics. So here in the screen, in the slide, you can see the applications related to flood mapping, DEM extraction, time series analysis, change detection, displacement mapping, shift detection, persistent scatter, image geocoding. So these all can be utilized. These all can be performed using Starscape analytics, and the access is to easy to use analytics across the Esri platform. So as I was talking about the integration part, so everywhere it's the power of Esri that we can integrate with any data. We can integrate within the software, so as we need not to change our data formats when we are switching from one software to the other. So it's the power of Esri that we give. So you can utilize for microwave, hyperspectral, any of the data that you're working on. So ideal. So as Preeti mentioned, that ideal is a completely programming language. So sometimes we are interested in going at the back end. We are interested in writing a code so as to perform the analysis. So ideal is it's the backbone of Envi that we are showing you. So it's based on ideal. You can write your own codes, you can write your own analysis so as to perform robust. So lots of functionalities available. It's a very you can say it's very easy to use language, very interactive, very integrated language with other software. Also, you can ingest the data and you can work on. You can customize various tools within Envi and Ideal. You can create customized tools in Ideal and bring them to Envi and even Arc Pro. So you can make customization tools. You can create your own Envi toolbox. You can in Ideal for a specific application. Like for example, if you want to perform a deep learning, you're performing any deep learning application for classification of any, you can create a tool for that in Ideal. You can consume the machine learning capabilities within Ideal. So in the next slide, I have mentioned that machine learning capabilities are in Ideal. You can use the K-means, you can use neural network, you can bring TensorFlow, you can bring Keras, you can bring the open source libraries that are present. You can bring all those to Ideal and have a complete machine learning capabilities within Envi only. The integration part. So it's better that I show this to you in the software so as to give it a more meaningful insight. Coming on to Envi Deep Learning. So this is the deep learning module that we have. So we have a deep learning guide map where you can train your model, you can classify a raster using a trained model, even you can refine a trained model. So it's not like once you have trained a model, you cannot change the parameters, you cannot change the analysis. So you can retrain your model. You can see how the model is performing. You can test your installation and configuration of your system. So before starting any analysis, you can even change the metadata going at the back end in the model maker. So here, if you see, it's a tornado affected area. It's a drone captured image that is captured. So using deep learning, I have classified this whole area into 4 classes, which is roof damage, structural damage, rubble, and blue traps. So this whole data was a very heavy data that I have used. So you can utilize it. So in my system, it has taken for starting from training your data, training your model, to approximately 3 to 3.5 hours. So depending upon your system configuration, it will take time. But you can save this model, you can iterate this model, you can do it, you can perform this, model for classification of multiple images that you are capturing. In this way, you can take the deep learning. So I have not written any single line of code for performing this analysis. So you can see the accuracy of this. So these are my blue traps. So here, if you see, these are the blue traps. This is the roof damage that is happening. So it will be a roof damage. So you can see these all are very so I'm achieving almost 97-98% accuracy depending on the training data that I am giving. Coming on to Sardscape. As I was mentioning about Sardscape, so lots of functionalities available, starting with the interferometry, focusing, filtering module, ScanSAR interferometry, polarimetry. So lots of tools are available for performing the analysis. For this, I have captured a pre and post disaster image. So here is a pre and post disaster image of Barpet area that I have used. It's a Sentinel-1 image. So using intensity time series workflow, I have created a filtered flood map. I have created a flood map just highlighting which are the flood areas, which are not flooded areas. So these are my flood areas. So clearly you can see these are the flooded areas that is that has happened over the time, and this one has my known flooded areas, which might be the permanent water bodies or any land affected areas. So here you can use the Sardscape. Now coming on to ArcPro, so as to show the integration part. So here, if you see, it's my toolbox of ArcPro. So you might all be using ArcPro. It's a completely revolutionized version of ArcMap that we were using. So you can have this ArcPro. You can analyze 2D and 3D in a single frame. So that's the advantage of ArcPro. But coming on to the Envi tools in ArcPros, you can see we have all Envi tools, majorly used Envi tools integrated within the software, starting with Envi Analytics, change detection, classification, thematic change, Envi deep learning. You can have a deep learning module within ArcPro from Envi. Coming on to Sardscape Analytics Engine. So in here, I have used this Sardscape Analytics Engine to perform the analysis using SAR flood mapping. Very easy to use. You just need to define a pre-event image. You just need to define a post-event image, define your AOIs, define a DEM, and all these features are taken care at the back end. So what?
Viman, your slides are not moving.
I'm not showing slide. I'm showing demo.
Then your screen is not visible.
Wait.
It's still on slide number 28.
Sorry. Is it visible now?
Yes.
Yeah. So as I explained about the integration part, so you can see here the integration. So all the tools related to Envi, related to SAR Analytics Engine, related to Envi Deep Learning, related to Envi Analytics are present in ArcGIS Pro. Using SAR Analytics Engine, I have created a flood mapping. So here you see it's very easy to use. Just need to define the post-event and the pre-event images. It can be multiple images. So the stacking will be done at the back end. So all these steps related to creating your slope map, creating your aspect map from them, so it will be taken care at the back end. So you need not to create it separately from the software, from the at your own. So it will be taken at the back end. You can define your AOIs, and all the other things will be taken care by the software automatically, depending upon the type of data that you are using. So you will have a flood map like this with an AOI listed. So only the part within the AOI will be used for performing the analysis part of the software. Now coming on, just to show you, I guess I missed out with deep learning part. So Envi deep learning, it's very easy to use deep learning. So you can train a model, you can classify raster using a trained model, you can even define a trained model. So it's not like you have once trained, you need not, you can't retrain your data model. So you can retrain the model using Envi deep learning. For this, I have done an analysis. Here you can see here my whole, it's a tornado affected area, it's a drone captured image. So I have classified it into 4 classes. Here you can see the accuracy. So I'm having almost 98% accuracy for this model. You can see here, these are my blue traps. This is my roof damage. So you can clearly see all these are roof damage, structural damages. These is my rubble. So depending upon the training data that you are giving the software, you will have an accuracy about of your model related to that. It's all on your training data that you are giving. Now I'll again switch back to the presentation. Yes, this integration is done. Now you can join this GeoNet community for regular updates related to Esri community, related to the latest trends that's happening over the GIS and remote sensing domain. So you can go and subscribe for that. And if you have any questions, so you can write a spark to info@esri.in. Thank you for your patience and sorry for the technical glitch that we faced. So thanks a lot for your cooperation.